Hi, good evening to all. How's life is going on? Is it good? And some people will say that do not ask tough questions about life. So we'll ask the questions about the series. So how's the series going on? And do let me know I'm audible to everybody. I'm audible and visual to all. I'm looking at the chats. Do let me know, please. Cool, yeah, cool. And anyhow, I hope everybody already knows that this is a 150 days marathon. This series is not just a series, it's a key to success. Maybe success for your coding interview, right? And right now, what we have covered so far is that math series we have completed. Arrays series means the basics of array. The problem statement which were only individually dependent on the array are completed. Now we'll see some mixing combinations of arrays with other kind of algorithms. Cooler. So now today what we'll do is that now our running series is array with two pointer. So we'll understand what is two pointer approach. Yesterday also we have solved one problem statement, but now we'll understand like what is the two pointer and how we can approach the problems. Okay, cool here. So first do let me know, am I audible to everybody? I'm looking at the chats and waiting for the names. Waiting for the names. Cool here. Probably I believe yes. Cool here. So now what I want to show you, I want to show this problem statement. Today what we are going to solve. The problem name is sort colors. One LeetCode problem again. And this problem statement has been asked in Amazon, Apple, Bloomberg, Facebook, Google, LinkedIn, Microsoft, Oracle, PayPal, Uber, Yahoo, and in many more companies also. So because this problem statement has something unique, something which can excite you, that's why this has been asked in multiple companies. So because it's a repeated problem in multiple companies, maybe this problem can also come in your coding interview, right? So that's why we're covering this here. And anyhow, in this series what we are covering, which is important, right, which has been asked somewhere or which is important, that's what we are covering, right? Cool here. But I'm not looking many more comments in the chats. Do let me know you're able to understand the problem statement. We'll go to the LeetCode, then we'll read the whole problem statement and how's everything going on. Do let me know. I'm waiting for the chats. Cool. Yeah. And I know few people are watching this live by sitting over the bed, having a snacks. Right. So I'll go to the Google and here we will search for LeetCode and here we'll search a problem statement. Okay. Here we will search. Okay, Vinitha. Cool. Now, here we'll search a problem statement, sort colors. And trust me, this problem is super important. And anyhow, if you're following this series, you just got lucky. Because after completing this series, you will have a really good confidence in problem solving. You won't be stuck in the coding interview itself. Cool, yeah, cool. Hi, creator Mukesh. Cool, yeah. So now I'll search for the problem statement. And problem statement is sort colors. Sort colors. Let's see the color of life. Clear. So I'll search for the problem statement. Now here we'll read the problem statement very carefully because this is super important. Okay. So given an array nums with an object colored red, white, or blue, sort them in place. So what we have a nums array where we have an objects. Those are colored red, white, and blue. What we have to do, we have to sort them in place. In place means you cannot utilize any other data structure to solve this problem. Okay, cool here. So that objects of the same color are adjacent, which means that like adjacent means this should come together. Like red should come together, white should come together, and blue should come together. Okay, with the colors in the order red, white, and blue, which means you need to sort them. First, red, all the red colors should come, then all the white colors should come, and then the blue colors should come. Now they're telling we will use the integers 0, 1, and 2 to represent the color red, white, and blue, which means 0 for red, 1 for white, and 2 for blue, respectively. Okay. you must solve this problem without using the library sort function, because we know that it's a sorting problem. If we directly use arrays.sort, which is a library sort method, if you will use that, this problem statement will solve automatically. So in this case you're not doing anything, which means if you write this arrays dot sort arrays dot sort, and if you write nums, if you write nums here, right, nums. So this problem statement will solve automatically, but this is not a right approach, because anyhow they have asked for the logic for sorting, and you're just utilizing an existing method, which is not an applicable one, right? Which is not a good way, and they already have denied in the problem statement itself that you must solve this problem without using. And what we are doing, we are using this. So this is not applicable, right? Not applicable. So this should not be a case. So what should be the another scenario? What should be the another scenario? So now we have to understand this problem. Again, whenever you solve any problem over the LeetCode, Arvindan, can you solve in C or Python? Actually, in this whole series, we are following Java, but I didn't see a lot of people who are asking for any other specific language. The target is 50. Once I'll see 50 comments on a particular language, we'll start. But anyhow, the maximum people are comfortable with Java, because we already posted, I asked for the language in the first video, and mostly people are asked for the Java. So we're continuing in Java. But when we'll see multiple comments for a specific language, then maybe we can solve in multiple language along with Java. Okay, very good evening, Siddharth. Cool, yeah. Dutch national flag algorithm. Yeah, we can say, but here what we have to do, whenever you solve any particular problem, you remember that you see the topics here. Maybe you can have your thoughts, your logic concentric, like on which algorithm you need to think about. Maybe you're not thinking about multiple logics, right? So here this problem based on array, that's we already know. Again, two pointers and sorting. Directly sorting we cannot perform, means existing method we cannot use. But if arrays.sort works, which means all the sorting algorithm are applicable here. You can implement bubble sort, insertion sort, quick sort, merge sort, anything, right? Anything you can implement here. But they have the time complexity is very much high, right? Even the best case scenario means you are using merge sort, right? So that will be big of and log n, right? That is also the maximum time complexity. So what we want to optimize solution. Is there any way that we can write this solution in linear time complexity? That's what we have to think about, right? So let's see if it's mentioned like two pointer. Let's see, can we do it? Let's see, can we do it? Okay. So now here, what I'll do is we have this num array. Okay. Now what I'll do, I'll take this input value and we'll try to figure out the logic how we can utilize two pointer. Okay, anyhow in topics it was mentioned like it was a two pointer, and anyhow when you have some problem like for sorting, two pointer is always helpful. Okay, two pointer is always helpful. Two pointer means you will take two pointers, those you will move based on the certain situations, and that will solve the problem statement. We'll go to the slide part and we'll understand. Okay, but first we'll see the input case, like what is the input value. Input value is 202110. So 202110. I hope I've already done this slide. So cool, yeah. I'll take this input value. Okay, I'll take this input value, and I know all of you like a color yellow, so I'll take that color yellow here. In color, that should be yellow. Cool, yeah. So what we have nums. In this nums, what we have already, we had input 202110. 202110. So now how we can utilize two pointers? Okay, so whenever you have this kind of problem, just utilize the two pointer. How we can do this? Anyhow, we need to do a sorting. So you remember in the bubble sort for adjacent element, we were taking the two pointers, right? And on the same place, we were comparing the things. Let's see, is this work here as well? So what I'll do is that if I ask you normally in the real life, how will you solve it? Okay, in real life, how will you solve it? Correct, anonymous, please. Correct, yeah. So now, sir, can we just count the number of zeros, ones and twos, and count them, then put them into an array? Yeah, that is possible. That is possible. That is a one solution also. Yeah, that is also one solution. We'll implement this as well. A good idea. Okay. The second solution, I'll implement that one which you suggested. Cool. Yeah. So this is solution number one. Solution number 1. Okay, so now if I ask you normally in life, so what you will do, you know that you have three values, right? Three values: 0, 1 and 2. So what you will do, you'll think like in a way, like what I'll do, maybe I have a one mid pointer, which let's, I'm assuming mid should be on 1. So if I get 0, I'll drop that value in left. If I get 2, I'll drop that value in right. That can be a way. Yes or no? Tell me. That can be a way. So now let's say we have 2. I'll drop this value in right. We have already 2. If we have 0, we dropped in the left. Again, we have again 2. We'll drop in the right. Again, if we have 1, we keep remaining right here. Right. Again, if we have 1, so what we can do, we can insert this and we can update this mid. Right. And again, if you have 0, then we can insert it here. So look at this. This everything has been sorted automatically. Right. Already thing has been sorted. So this can be one approach. This can be one approach. But how we can implement in the coding itself? We do a like yesterday problem from backside. Uh, Probably that is also possible using hash map. No, actually, if you're using hash map, then you're using any extra data structure. Okay, but they have mentioned like do it to in place. But yeah, by using hash map, this can also be solved. Okay, there is a possibility to solve this problem. Now counting the frequency, the possible one. Cool, yeah, cool. So now what we can do for two pointer, let's assume, okay, now I'm telling you the whole algorithm, what we are going to do in the two pointer here. So what I'll do is I'll assume two pointers here. Right now I'm assuming left is here and I'm assuming mid is here. Okay, which means that we do not have any sorted part initially. Now at the end I'm assuming this is the end part. And if I'm writing left, so I'll write right, because right and left sounds good. If I should have written here start, then this would be end, right? So now here we have what? We have assumed like the left and mid are starting from 0 index. So what I'll see that if I get 0, I'll swap that value to left. If I get 1, I'll increase my mid. If I get 2, so what I'll do, I'll reduce my right by swapping the values. Cool. Let's see how we'll do this. How we will do this. Okay. So in the first step, what we have get 2. Right? At mid, every placing will do by comparing the mid. Because if it is 0, then drop in the left of the mid. If it is 2, then drop in the right of the mid. I hope the whole logic is clear to you. Right? So now this is 2. This is 2, which means 2 will drop in the right. So how will drop in the right? What will do? You will swap with the right value. You will swap with the right value, which means that you will update this 2. You will update this 2 with to what? With the right value. And right value was 0. Okay, so you have updated, and this 2 will be went to the end at the right place. At the right place. Now, now here I'll change the in color again. Now here we have a remaining values. Remaining value 0, comma 2, comma 1, comma 1. But now tell me, once this has been swapped, so our mid should be, our mid should be remain here right now, because anyhow we have updated something at the right. Right? So again, if there will be a bun, so we could have bun here. So anyhow we have to check again, which means left and mid should remain on the same place. But if we have inserted 2 at the right, so there is a no meaning to keeping this right pointer here. Which means that we can reduce our right pointer from here to here. Yes or no? Again you will compare. So you will see that what we have now. So again you will compare the value. You will compare the which value? The value of mid. What you have at mid? You have 0. What you have at mid? You have 0. So if you have 0, we wanted to keep 0 at left. If you have 0 at the left pointer, then your mid should increase also and your left should increase also. If you have 0. Yes or no? So which means that your left should come here, because in left we have 0 now, and your mid should also come here. Now again we'll compare this value. Again we have 0. If you have 0, then your left should increase, which means that in left you have the right value and your mid should increase. So now we are pointing where? We have arrived here 0, 0, and now at 2 our left is pointing, our mid is pointing. Right? Our mid is pointing. And now after that we have 1, 2. Right? And this here we have right. So now what you want to do, you want to compare again the value at mid. Value at mid is 2. If you have value at mid 2, what we were doing? We were swapping with the right. If you have 2, we were swapping with the right. So now look at this mid value. We have 1 here. So now you will swap it. You will swap it. All right. So I'll change the ink color. And now if you will swap the mid value with the right, what you will have? Tell me what you will have. Again, first few things I'll write in the yellow color itself. Those are the same as previous 0, 0, comma. Now this bun value will be changed, and bun, comma, this bun will be changed. I'll leave the space for different color, and here I'll change the ink color to red for showing you the swapping. So now what happened? This bun will come at the place of 2, and this 2 will come at the place of 1, because 2 will insert at the right part. So now here 2 hatch came, and here 1 hatch came. So now if you got the right, you have to decrement the right. If the right was here, right was at the 1's place. Now by decrementing, right is now here. Right is now here. Now tell me, if right is here, then where is the left? Left was and the mid was at the same place. So here the left exists and here the mid exists. Again compare this value. You got the bun, and bun means the value of mid. If you have the value of mid, just increment the mid. We can left it on the same place, because all the left value are here 0, 0. So mid should increase. Now mid should come here. Mid should come here. Now what happened? Mid and right are same. Mid and right are same. Now check, is this 1 or 0 or 2? It's a 1, which means mid will increase. Mid will increase. So which means that now the value of mid is greater than the right. So it is possible? No, it's not possible. You should stop executing. So there is a comparison between mid and right. We will do this when mid is less than or equals to right only. Till then we'll compare. If we get the mid, we'll increment the mid. If we get 2, we'll swap the value of right and mid. If we get 0, we'll swap the value of left and mid. Right? So all the 0 will come at left, all the 2 will come at right, and will remain in the mid. 1 will remain in the mid, and we will keep incrementing mid. So that's it, the understanding of 2-pointer here. And we are utilizing right and left as a 2-pointer and mid as a iterator. Right? Left and right are the 2-pointers, because with the help of 2-pointer, you're performing all the operations. Making sense? Right? So now we'll go to the code, then we'll do a dry run. You'll understand this problem statement very clearly. Okay? Right now you have a basic fundamental understanding, which is if we have 3 values 0, 1, and 2, I'll assume 1 as mid, and I'll drop all the value of 0 at left, all the value of 2 at right, and we will have a sorted array. Right? Cool, yeah. Cool. So now what I'll do, we'll go to the code window and we'll write the code. Okay? Then we'll understand the another approach also. I guess somebody has suggested previously. Okay? So now here we came. So what we'll do, we'll define our left at starting at 0 index. We'll define our mid at starting at 0 index. Now we'll define our right. So now right was the last element, which means nums dot length minus what? Minus 1, which means we are pointing to the last element. And we'll keep doing this while mid is less than or equals to right. Right? We'll keep doing this. We'll check here if nums mid value is what? If this value is 0, which means that we have to perform swap for the left. So we'll perform the swap. We'll copy that value in the temp. So nums mid, we'll copy the value of the nums in temp, and we'll point this value to the left part, right? So value of the mid, and we want to assign this value into the left. So for what we'll do is that first we'll keep the value of left to place on the mid. So nums left. I hope the logic of swapping everybody already understand. So that should not be a problem. I strongly believe this. So now at nums left, we have swapped the value of mid and left successfully here. Now once you have done swapped, you have to increase the left pointer, right, and the mid, because now at left you have 1, 0, right? So your mid and left should be increased. Again, the another case was that what if we have 1? If nums mid is 1, this is 1, just increase mid, nothing more, right? If this is mid, just increase mid, nothing more. So mid plus plus. Again, if this is not the case, which means that you have mid is equals to 2, right? Nums mid is equals to 2. So in that case, again, you have to perform sub between mid and right. For 2, you have to perform sub between mid and right. So int temp, I'll take a temporary variable, I'll copy the value of mid, nums mid, and again, what we'll do, we'll update first mid. So nums mid, and what we'll do, we'll put the value of the right. Nums right. Right. Now what we'll do, we'll update our right. Nums right, we have swapped the values, right? Nothing more. Nums right is equals to what? This will be the value of temp. And what we'll do, we'll decrement our right. Because any of the last value is sorted now. The last value is sorted now. Yes or no? Last value is sorted now. Problem number Ruchi is 75, sort colors. Okay. Oh, Prince, you're here. I hope you're fine now. Very good evening, Prince. Prachi, the problem number is sort color 75. Okay, LeetCode problem. And if you have skipped, then watch this problem, this whole video from starting. You'll understand in how many companies this problem has been asked and why this problem is important. That's more important, right? Cool, yeah, cool. So now what we'll do, right minus minus. Okay, right minus minus, because the last value is already sorted, we have put it there too. So now look at this, the return type is void, which means you don't have to return anything. That's why it was in place. And you remember the meaning of in place yesterday we have discussed, which means you are not utilizing any other data structure, you're utilizing this nums itself, right? So now here what is happening, from this value you are dropping all the one to the left. If you have 1, you're just incrementing the mid, and again if you have 2, you're dropping all the value at right. So that's what you're doing. Right? So now I'll run this, and again we'll submit this. Okay, it's worked fine, beats 100%, 0 millisecond, very nice solution. And can somebody tell me the time complexity of this solution? Anyhow, what we are doing is that in the worst case scenario, we have to iterate this whole array, this whole nums array. So which means that what will the time complexity? Time complexity will be big of n. The time complexity will be big of n, because in the worst case scenario, you have to iterate the whole nums array, right? So the time complexity will be big of n. Cool here. So now I'll do a dry run of this as well. Okay, then we'll understand the different solution maybe. Okay, sure, Sarthak, I'll do that. Now cool here, we'll copy this solution and we'll paste here in our slide to understand it more better. Okay, and here I have to keep this, I guess. We'll come here, I'll paste that solution. For that I have to take a text box. Cool here. Oh no, it has reached more than the size of our, don't worry, we'll reduce the size of the text. Okay, it's 18. I'll do one thing, I'll make it 16, still out of box. 14 is good. I'll change the color to be, no, good, I guess it's good, right? So now we can have a dry run. From current slide. Cooler. Now we'll understand how are the solutions working. Okay, how our solution is working. Now what I'll do here, what we have nums. I'm assuming the first test case. Nums we have as what we had as a input value. Somebody remember 0, 0, 202 110. 202 110. 202 202 110. Cooler. So now here what's happening in starting, we at step number one, what we done, this is left, you're assuming this is left and this is mid, it's an assumption, and this is right, length minus 1, right? So this is what we have cleared. Now we want to run till mid is less than or equals to right. So now in step number 1, what will happen? We'll check the condition. Is mid equals to 0? No. The value at nums mid is what? It's 2. So which means this condition will not be true. Again, it is not 1, so this else part will also not be true. else part, and this else part will be true, right? Because any of this is not the case, this is not the case, and this will execute. So which means that we have to swap for right value. We have to swap for right value. So now what in array you will have, you will swap this value to right. So now here is 0 at right, at mid you have 2. So which means you will have 2 at the place of mid, and 0, comma 2, comma 1, comma at the place of 0 you will have 2. You will have 2, right? So that has been swapped on the step number 1. Now what will happen? You are doing right minus minus, right? Because last value has been sorted. So now previously right was here, now right is here. Now right is here. So now comes to the step number 2. You'll check is are your mid less than right? The value of right was what? The length minus 1, and the length was 6. So 6 minus 1 becomes 5. Now you have done right minus 1, which means now right is 4. Previously right was 5. Yes or no? So now in step number 2, you'll check the condition. The value of mid is still 0, 0 less than or equals to 4. Yes, this is true, which means that again you will have this nums checking, right? So you'll check at nums mid. Mid is still 0, right? Mid is still 0. Mid is 0 and left is 0, right? So now what you'll do, you'll check this. Is this value 0? Yes, the value is 0. If the value is 0, what you have to do? Which means the value at the right, at the left part, it should remain in the left part. You'll do a swapping. Even if in this case it will remain same, because it doesn't impact any of your pointers, the same pointer, left and right. So what will happen? You will swap the value in itself, and this will remain same. But what will happen? You will increase the left and mid, because leftmost value you have 0, and your mid and left will be increased. So now what will happen? You will have the same array, but the pointer will change. The pointer will change. So now here you have right, which is still 4, but left and mid has been increased. So now left came here and also mid came here, right, in this step. So now in step number 3, you'll check the condition again. So now the value of mid is 1. So now tell me, is 1 less than 4? Yes, it is, which means it's true. So now what you'll do, you'll check again. At mid 1, tell me at mid 1 what you have. You have again 0. So if you have again 0, you will increment left and mid pointer, because the left part is already sorted, right? So you increment them. So now what you will have? You will have again 0, comma 0, comma 2, comma 1, comma 1, comma 2. So now what will happen? Tell me what will happen. Your mid and what? Your mid and left will come here, right? So now what you will do? You will check the condition again. Is this mid is equals to 0? No, it is not. Is it equals to 1? No, it's not, which means else will execute. If else will execute, you will swap the value of right and mid, because you want to point out all the values of 2 to the end. Yes or no? Yes or no? Right? That's what you want to do. So what you'll do? You'll swap them. So now what you will have? Tell me what you will have. You will have here, you will have, after swapping 0, comma 0, comma at the place of 2, you will have 1, 1, comma 1, comma again this 2 will come at the place of 1, so which means 2, comma 2. And now your mid is still on the same place, and left is also on the same place, but right has been updated from this index to this, which means previously the value of right was 4, now it will be 3. So right now you are here, so right is here. So you will execute the step number 5. I'll erase from the top, okay, because we don't have a lot of space. I'll erase from the top, and I hope it's fine for everybody. Okay, I've erased this from the top. Now I'll change the color as well here, because this is very cool here. Cool. So now on step number 4, you'll check the condition again. Is your mid, the value of mid right now, which is 2 at second index? So is your mid, which is 2, is 2 less than or equals to 3? Yes, it is. It is. So which means this while loop will execute again. You again check at mid, at second index, check. Is this 0? No, it is not. Is this 1? Yes, it is. If this is 1, which means you are at the mid place. You're at the mid place, right? So what you have to do, you have to increment your mid pointer. So now the mid pointer will come here. So now what will happen? You will have an array here, which will have the value 0, 0, 1, 1, 2, 2. What has changed? Previously you were pointing right here. You're pointing left here. But at the right, you're pointing the mid also, which has been updated, right, by this mid plus plus. Now in step number 5, what will happen? You'll again check the value at mid, which is 1, which means mid plus plus will happen. But now you see, in this case, the value of mid was 3, the right was 3, which is true. But in step number 6, what will happen? Mid will be increased by 1, which means that the value of mid will be 4, which is not less than or equals to 3. So this will stop executing. While will stop executing, which means that now you have the array which has been sorted. So it was a two-point approach. I hope it's clear to all. I hope it's clear to all. Right? I hope it's clear to all. Now the another possible solution which Siddharth was suggesting is that let's say we have this array nums, we have this array solution number 2, right? We have this nums array which is 2 comma 0 comma 2 comma 1 comma 1 comma 0. So what we can do, we can count the frequency of them. Like we will create another array where we'll utilize their indexes as value. So now we'll create the new array with size 3, which means that we will have 3 values. Okay, 3 indexes: 0 index, 1 index, and 2 index. Okay, so at 0 index we'll do plus plus the number of 0 we have in this whole array. So how many 0 we have? We have 2 array. So we'll do here 2. Again at 1 index we'll put the frequency of 1 value. So this comes 2 times. Again at the second index we'll count the frequency of second. So which is 2 times. So we'll write it 2. So now you have this frequency array. What you can do is that you can push this value number of time in the nums itself until unless this value becomes 0, which means what you can do in nums you can push this index, which means how many times? This much time, the value times. So which means you have dropped 0 at 0 index. Now this will remain 1. Now again you put the another 0, this will remain 0. Now if this is 0, which means all the 0 value you have inserted, again what you will do, you will have 1. If the index at 1, right, if this frequency at 1 index is not 0, till then you'll keep doing this, right? So what you'll do, you'll insert 1 time, you'll reduce this will become 1. Again you'll insert 1 time, 1 again. So now this frequency of this will become 0, right? And again you have 2 now. So you'll see, is this value on this index is 0? No, it's not. Then insert that index value. Again what you will do, you'll reduce it by 1. And again what will happen, you'll insert 2, again you'll reduce by 1, this will become 0. Then if all the value of this frequency array becomes 0, you will stop executing. So that's how also you can do. Okay, that's how you can do. Okay, we'll code this in a minute, but anyhow this is a topic of frequency counter. Okay, array is a frequency counter, the solution we're implementing. It's not a 2-pointer, but then that will be a array is a frequency counter. But okay, cool, yeah, we'll implement that as well. So I'll erase this problem. Now what we'll do, we will have an array int arr, and this array will create of size what? Of size 3, right? New int, because we have only 3 values, 0, 1, 2. So I want to use those values as an index. So I'll create integer array with the size 3, and which is a fixed size. Okay, anyhow you're not consuming the n space, so it's still in place solution. Okay, so now what I'll do, I'll count the frequency of each value. So let's say I'll utilize this for each loop. So now I'll take the value from the nums array and I'll count the frequency. So arr, I'll use the value of nums as index for frequency for this arr array. Okay, so now here I'll write num, and every time on that same index we'll do plus plus when we get the value. Okay, so that's how you counted the frequency. Now what you can do, you can have 3 while loops. Like if this arr what? Let's say you can have one thing for inserting the value, you can have I, a pointer, which can probably insert the value in the nums. So if at this point where if at point I, which is a value, what we want is that we want, like, if on the 0th index, okay, if on the 0th index value is greater than 0, if on 0th index value is greater than 0, then what you need to do, you need to update your nums I, and nums I should be what? 0. And then you reduce the frequency, the value, the amount of value in the array itself. So now arr at 0 index will do minus minus. So value reducing. Now you want to increment this pointer to point out the next value in the nums, you will do I plus plus here. Okay, now similarly for 1 and similarly for the 2. So I'll copy the same thing because we want to copy all the value of 1 here. We'll do the same thing. What we'll do, we'll take the value from the 1 index when they're greater than 0, and again all that value, if they're greater than 0, then we'll keep putting 1 value here, and we'll keep reducing the value available on the 1 index. Okay, here I guess I've seen. Okay, Lunt all, maybe you have some issue with your speaker. Okay, cool. Now, yeah, so now what I'll do for the third one part, when we have indexes as, I'll explain you this how this is working. Okay, don't worry. So you don't have to worry about how this will work. But that is logic which you have suggested, Siddharth. So now, if you are writing 2 here, what you can have, you can insert 2 at all the values, all at that place. Okay. So now here, what have you have done? Now your array is sorted. You run this, it will work fine, I believe, because your logic sounds good. Yeah, correct. Your logic worked. Congratulations, Siddharth. You thought correctly. Okay. It's beating 100%. It's a fine, perfect solution. So now how is this working? How is this working? Again, here, what you have done here. Again, what you have done here. What you have done, you have counted the frequency of all the elements. So like this is ARR. I'll write a comment here. I'll write a comment here. In the value, you will have ARR, and this ARR will have the values what? Like, look at this index. At 0 index, you will have 2 because you have 2 zeros. Again, at 1 index, you will have 2 because you have 2 ones. And again, at 2 index, you will have 2 because you have 2 twos. The frequency of 0, 1, and 2. Okay, and the indexes and counting as values. Okay, so now here, look at this. If this ARR 0 is 2, which means 2 times you had 2 in the given array, in the input array, yes or no? So now, when this ARR 0 is greater than 0, is this value, which means you haven't drained all the value of the 0 places, right? So what you'll do, you'll update at initially I is 0, which means that at nums 0, what you will do? Look at this. At nums 0, you will update the value. You will update the value. Update the value what? You will update 0. Again, what you will do? You will reduce the frequency. You will reduce the frequency here. Right now, what's happening? This is happening right here. This is happening right here. Okay, and now here you will reduce the frequency. You will reduce the frequency of what? You will reduce the frequency at ARR 0. So which means that you will have ARR here on 0th index. You are reducing the frequency, which means on 0th index previously you had 2. Now you will have 1, 2, 2. Right? So now you are doing I plus plus because at nums 0 we have inserted. Now the next value will come at nums 1. So now the value of I become 1 here. Again, what you will do? Again, what you will do? Look at this. This while condition is still true. Why? Because at ARR 0 you have 1, not 0, which is greater than 2, right? So what you will do? You will update the value at 1 index. Nums at 1 index, and 1 index will do what? You will put the 0 value. So now you will reduce the frequency in the ARR, which means this ARR will become what? This will become 0, 2, 2. Yes or no? Tell me. Yes or no? So this will happen, right? So now again, all the value, again what will happen? Because we have inserted 1, now this value, the value of I will be increased by 2, I plus plus. So now look at this. Is this true now? Is this true? At ARR 0, you have 0, which is not greater than 0, which means you have inserted all the 0 into the nums. Similar thing you will do for the 1 part. Okay? For the 1 part also. So which means that all the value of 1 will be inserted into at 2nd index and then on the 3rd index. And again on the 4th index and 5th index, we will insert the value of 2. And that's how this ARR will become complete 0, 0, 0, which means all the value has been inserted in place. And this nums you will have at the end here, the nums you will have will be the value holding 0, 0, 1, 1, 2, 2. I hope this makes sense to all. Do let me know, Siddharth. I hope your solution is clear. And this is what you wanted, right? This is what you wanted. So this could be another approach. Also, all the sorting algorithms can be another approach. And trust me, this problem statement is super important for everybody. Because this has been asked in multiple companies, and maybe in future this will also again be asked. So prepare this very well and also understand the pattern, how we are solving it. That is more important than the writing the code. Okay, the approach, how we solve the problem, that is super important. Okay, all, bye-bye. See you in the next live by tomorrow. Till then, keep revising these things, keep practicing, and try to solve the similar problems from here, similar questions from here. Okay, cool, yeah. Look at this. This is short list. Yeah, similar problem. So you can solve that also. Bye bye to all. Creating a variable count 0, count once. Yes, we can do that as well. If you're not utilizing this, you can have that as well. Okay. Time complexity for this, again, you're doing this for n time. So what will happen? Let's say if you have all the zeros in this nums, so you have to run this while loop till n time. So this will have the time complexity of big of n, big of n, big of n, which means big of n plus big of n plus big of n, and the total will become 3 big of n, and the constant we ignores, so the time complexity will be big of n. The final time complexity will be big of n. And space complexity is constant because this is not depend on the user input. So still it's the auxiliary space. This will not consume as a space complexity. So the time complexity for this solution also, TC means time complexity will remain big of n, and again the SC space complexity will remain big of n. Big of n. I hope it's clear to all. Okay. So which company asked this question? Yeah, in starting slide, I've shown you. Maybe I'll show you once again. This problem has been asked in Amazon, Apple, Bloomberg, Facebook, Google, LinkedIn, Microsoft, Oracle, PayPal, Uber, Yahoo, and in many more other companies. Because I don't want to create a very long list here. Trust me, this problem is important. So anyhow, you need to understand the pattern. You need to understand the solution. You need to practice the similar questions as well. It is super critical. Okay, then bye bye to all. Let's see you in the next live. And again, keep subscribe this channel, keep subscribe and press the bell icon by which you can get a notification for the upcoming upcoming videos. Also share this video or live to your friends. May this can help them as well. Right? Cool, yeah. Bye bye to all. Bye bye to all.